page 76, numbers 61 through 89 odd. Let's go ahead and get started with the problems today. On numbers 61 through 73, the directions say to find the domain. So we're going to find the domain, okay? Well, first of all, guys, as I look at this problem here, number 61, is really pretty obvious. I mean, x can be anything. There's no limitations. Think about it. There's no fraction. There's no square root. There's nothing that would say, hey, you can't put this number in for x. So, using words, we would say the domain is all real numbers. Okay. Now, if we're going to use inequalities or interval notation, students, what we need to do is get a picture of the all real numbers on a number line. To be honest with you guys, think about it. I mean, it's just everything. So I really don't know how to use inequalities. I guess you could say x is greater than or equal to 0 and x is less than or equal to 0. I really don't know what to do with inequalities. Interval notation, it would simply be from negative infinity all the way to positive infinity, okay? Because it's all real numbers. Alright, number 63. Well, guys, listen for the numerator. T right here can be anything. You can put any number in for t that you want to. It does not matter what number you put in for t. However, for the denominator, t cannot equal 0 because your denominator can never equal 0. So there we go, that's it. So for words, you would say all real numbers such that t does not equal 0, okay? Now, for interval notation or inequalities, think of a number line, and I would put an open point at 0, and that would put an arrow to the right and an arrow to the left. So using inequalities, I would say x is less than 0 or x is greater than 0, okay? Using interval notation, think about it. I start from the left, so it's going to be negative infinity. It goes to 0 and it stops at 0, so put a parentheses. Then it starts again after 0, so put a parentheses, put 0, and then it continues on to the right forever, so positive infinity, okay? Interval notation can be a little confusing, but the more you practice it, hopefully the easier it'll become. Okay, number 65. Obviously, because my index is even. If my index is 2, 4, 6, 8, 10, etc., then you cannot have a negative number under the radical. In other words, your radicand, which is what this is called, cannot be negative. It can be 0, that's fine, but it cannot be negative. So y minus 10 must be greater than 0, has to be, or equal to 0, sorry about that. Y minus 10 has to be greater than or equal to 0, so we're going to bring the 10 over and make it a positive 10. So now we have y is greater than or equal to 10. So there's your domain. You got it. Now let's put it in words. All real numbers greater than or equal to 10. Or if you want to use interval or inequality notation, let's get a picture of it real quick. Here's 0, here's 10. It's a closed point. It's a closed point, and it goes to the right, okay? So, here we go. For inequalities, you would say x is, or y is greater than or equal to 10, okay? Just like we had here. And then for interval notation, it starts at 10, and it's a bracket because it includes 10. And we're going to go to the right, which is infinity, okay? So there's the interval notation right there. Alright, moving on to number 67. Now students, I wish I did not have this square right here, okay? I wish it was 1 minus x, because I have an even index. I would take the inside and simply say that it has to be greater than or equal to 0. But unfortunately, I do have this squared right here. So here's what we're going to do. Remember, we talked about this. And we also did one of these in your notes too, where you have an x squared here. Okay, so what you do is you set it equal to 0. And you solve for x. So we're going to bring this positive 1 over and make it a negative 1. So we're left with negative x squared equals negative 1. Now divide both sides by a negative 1. X squared equals 1. Now take the square root of both sides. The square root of x squared is x. And the square root of 1 is positive negative 1. Okay? I hope all of this rings a bell. Then we put a number line over here. We're going to put negative 1 here. Positive 1 here. Now students, think about it. Please listen to me. Some students get confused as to whether to leave these points open or to close them. Okay? Well, look, guys, think about it. If you put negative 1 in, it makes the whole thing become 0. If you put positive 1 in, it makes the whole thing become 0. Are we okay with having 0 into the radical? Yes, definitely. So these points are definitely inclusive, or these critical values. Now, we have this region to check, this region, and this region, okay? So, let's start off with putting negative 2 in. Negative 2. So here we go. Let's put negative 2 in for x right here, and let's see what we get out. 1 minus negative 2 squared. When you square a negative 2, you get a positive 4. And 1 minus 4 is negative 3. So this quadrant here, this region, does not work. It's no good because we got out a negative number, and we do not want negative numbers into the radical. Now let's test 0, because 0 falls right in the middle of this region here. Plus 0 is a really easy number to use. So here we go. 1 minus 0 squared. 0 squared is 0. 1 minus 0 is 1. So this region checks. Alright. Now, let's check a number over here in this region. And so we're going to use 2. Alright. So here we go. 1 minus positive 2 squared. Positive 2 squared would be 4. So 1 minus 4 is negative 3. This region does not work. So, there we go. Usually, students, we start off using words, but I'm going to go ahead and start off using interval notation and inequalities because, look, I already have my graph. My graph's right here. So, using inequalities, I'd bring my negative 1 down, bring your 1 down, put your x in the middle, and put your arrows pointing to the left. Do you remember this from Algebra 2? It's called a conjunction. Okay? Whenever the graph goes apart like this, we call that a disjunction. Okay? Whenever the graph comes together like this, from here to here, we call that a conjunction, and you write it like this. Now, you really should write your answer like this. However, I'm not going to take 8 points off if you go like this. X is greater than or equal to negative 1, and x is less than or equal to 1, okay? I would accept that it's okay. It's not the best way, but it's okay. Now, interval notation should be really, really simple. It's inclusive to negative, starts here at negative 1. You put a bracket because it's inclusive. And it goes to 1. So you put a 1, and then put a bracket because it's inclusive. And there's interval notation. Now, if you're going to write the answer with words, I would say this here. I would say all real numbers between negative 1 and 1, and then I would put the word inclusive. Alright, and that's how I would write it with words. Moving on to 69. Okay, now we have 2 fractions, thus we have 2 denominators to worry about. So for this denominator here, x cannot equal 0. For this denominator here, obviously x cannot equal what? Negative 2. If I put a 0 here, the whole denominator becomes 0. If I put a negative 2 here, then the whole denominator becomes 0. So, here we go. write this in words, we would say all real numbers such that x does not equal 0 and negative 2. There we go. Now, let's get a picture of this. We have 0 and we have negative 2. So, we would have this part over here. We would have this part here. And we'd have this part here. So we have 3 parts to the graph here. So for inequalities, I guess we would say x is less than negative 2. And that would say, now listen to me students, this inequality right here goes for this region to the left, okay? Now, this region to the right, or this region in the middle right here, I would bring down your negative 2, bring down your 0, put x in the middle, and put arrows pointing to the left. A conjunction, x is greater than negative 2, x is less than 0. So this inequality right here, it goes for the middle section. Okay, so we'll put that up here. Alright, so this one here goes for this section, this one here goes for this section. So over here, obviously we're going to put x is greater than 0. Notice we're not putting equals underneath them, okay, because it does not equal negative 2 or 0, okay? Now students, for interval notation, watch carefully please. The domain starts over here going indefinitely to the left, so negative infinity, and it goes all the way to negative 2, and be sure and put parentheses. Then it picks up again at negative 2, non-inclusive, and it goes to 0. Then it picks up again after the 0, so 0 on to infinity, and there we go. Okay, not too difficult. Alright, number 71. Alright, now, this one's going to be pretty tough, so let's pay attention here, okay? First of all, for my denominator here, s cannot equal 4. Because 4 minus 4 is 0. Up here, we're going to have to take s minus 1 and say that this whole radicand right here must be greater than or equal to 0. Bring your negative 1 over, make it a positive 1, and we have s is greater than or equal to 1. So, my domain is all real numbers greater than 1, except 4. So let's write that down. All real numbers greater than or equal to 1, so that s does not equal 4. Okay? Now, let's go ahead and try inequality and interval notation. So let's get a quick graph up here. All the numbers are greater than 1. So we'll put our 1 right here. And it would be inclusive because equal sign here. S is greater than 1, so we know we're going to go this way. However, at 4, there's going to be a little break right here, okay? A little break there, then it continues on. Okay? So using inequalities, I would write it like this. I would put s, here's how I would write the domain with inequalities. S is greater than or equal to 1, so that s does not equal 4. Okay? Now for interval notation, well, it starts here at 1, so put a bracket and then 1 because it's inclusive, and it goes all the way until you get to 4. Okay? So I'm going to put a 4 and a parentheses, and then it picks up at 4, so parentheses 4, and it continues on indefinitely, so that's going to be infinity. Okay? Alright, hope that makes sense. Let's continue on. This one looks difficult, and it's actually hilariously, amazingly easy. Look, students, this is an odd index, so your radicand here can be positive, it can be negative, it can be 0, it can be anything. So there's really no restrictions on this radical here, okay? However, the denominator, it's very obvious x cannot equal what? 0. because that'll make the whole denominator become 0. So really, that's the only constraint that we have. So here we go. All real numbers so that x does not equal 0. Now let's get a quick graph of this. Here's 0. So we know it's going this way, and we know it's going this way, but it's not inclusive. Don't color that in, okay? It's not inclusive. So for inequalities, I would say x is greater than 0 and x is less than 0. Okay, so there we go. Now for interval notation, well, obviously it's going on and on to the left, so negative infinity, and then it goes to 0. Then it starts again after 0. And continues on to the right for positive infinity. Okay, so hope that makes sense, guys. There's the first one, and let's go ahead and continue on. Now, numbers 75 and 77, they want us to, it's really simple what they want us to do, guys. It's kind of funny. It's almost like Algebra 1. They give you these 5 numbers for your domain, and they want you to put those in and get out the y's or the range, so it's pretty simple. So in this equation here, if you put negative 2 in, and where'd I get negative 2 from? These numbers right here. We're going to put these 5 numbers in, okay? So if we put negative 2 in, you square negative 2, you get out 4. Now we're going to put a negative 1 in. If you put a negative 1 in here and square it, you get out positive 1. Now we'll put a 0 in. If you put in 0 and you square it, you get out 0. If you put 1 in for x, right here, square 1, you'll get 1. And then put a 2 in for x right here. Square the 2, and you'll get a 4, okay? So these 5 ordered pairs right here are the 5 ordered pairs for this function right here. Alright, let's take a look at the next one here. Number 77, alright? Okay, let's put a negative 2 in first, okay? Put a negative 2 in for x right here. Negative 2 plus 2 is 0. The square root of 0 is 0. Okay. Next we're going to put negative 1 in. So put a negative 1 here. Negative 1 plus 2 is 1. And the square root of 1 is 1. So negative 1, comma 1. Okay. Alright, let's take a look at number. Put a 0 in for x. Put a 0 in for x. Right here. And you will get the square root of 2. Alright? Because if you put a 0 in right here, 0 plus 2 is 2, and the square root of 2 is just square root of 2. Now, if you type this in and you got out decimal, that's fine, but you could also just write it like it is, like this. Okay? Next, let's put in 1. So we're going to put 1 in for x. We can do these in our head, guys. 1 plus 2 is 3, so the answer would be square root of 3. Or you could type it in your calculator if you wanted to. And lastly, we're going to put 2 in for x. Put 2 in for x. Let's see, 2 plus 2 would be 4. And the square root of 4 would be 2. Okay. So, put a 2 in for x. 2 plus 2 is 4. Square root of 4 is 2. Alright, moving on now. Numbers 79 and 81. These are pretty tough, okay? Now here's what they want you to do. They want you to try each one of these functions until you figure out which one of these functions, this one, or this one, or this one, satisfies this, okay? So let's try this and see how we do. First of all, I'm going to go ahead and put negative 4 in for x, okay? For this function here, so f of x equals c of x. Where the x is, I'm going to put negative 4, okay? And for the y, I'm going to put negative 32, alright? So negative 32 equals negative 4c, okay? Now, watch what I do here, please, students. I'm going to just find out what c is. Divide both sides by negative 4, and 8 is c. So I come up to c and I put an 8 here. Now that I found out what C is, let's see if all these ordered pairs satisfy the equation. If I put a -4 in for x, a times -4 gives me out a -32. Good, it checks. We gotta check all these. Now put a -1 in for x, okay? What's 8 times -1? -8. So when you put a -1 in, you should get out a -8, and we don't. We get out a -2. So this is not the function. Okay, so we have to go on to the next one. Now we'll try this one here. Okay, this is going to take a little bit of time. Now let's go and put -4 in for x and -32 in for y. So -32 equals c times -4 squared. Okay, so I put -4 in for x and -32 over here. Now square the 4 and you get 16c. Alright, divide both sides by 16 and -2 equals c. So where this c is right here, we're going to put a -2. Okay, a -2. Now let's see what happens. Alright, let's put -4 in. -4 squared is 16. 16 times -2 is -32. So this one checks. Alright, put a -1 in. When you square a -1, you get 1. 1 times -2 is -2. This one checks. Put a 0 in for x. Square the 0 times 2, you get out a 0. This one checks. Put a 1 in for x. 1 times 1 is 1. Times a -2 would be -2. This one checks. I got out -2. Now we're going to put 4 in, and we better get out -32. Put a 4 in. 4 times 4 is 16. Times -2 is -32. So this model right here, hold on one second. This model right here is the model that you would use for number 79. Okay? Alright, so there we go. We found it. Now, moving on to number 81. Okay, number 81. Let's go pretty fast here. Here we go. We're going to put it right away, though. Can I be honest with you guys? Look at this, guys. There's a big hint right here. Always try to save yourself time when you put 0 in. You get out what? Undefined. Well, which one of these when you put in 0 gives you undefined? Wouldn't it be this one right here? If you put 0 in for x, you would have 0 in the bottom, in the denominator. So this whole function becomes undefined. So I'm pretty sure this is the function I want right here, but I'm still going to check it and make sure. So here we go. Where the x is, I have r of x equals c over x. Now where the -4 is, I'm going to put that for x right here. And where the y is over here, or the r of x, whatever, I'm going to put -8. Okay. Now, so I really have -8 equals c over -4. So let's multiply both sides by -4, and we get 32 for c. 32 equals c. So I'm going to come over here, and where c is, I'm going to put 32. Alright, 32. Now let's check each one of these points and see if they all work. When I put -4 in, I better get out -8. Put a -4 in right here. 32 divided by -4 is -8. Okay, so that one checks. Now when I put a -1 in, I better get out -32. Put a -1 right here. 32 over -1 is -32. So this one checks. Alright, obviously this one here checks, because if you put in 0 for x right here, you're going to have undefined. Okay, now put a 1 in for x, and what was up here for c? 32, I believe. Put a 1 in for x, and when you put a 1 in for x, you get out 32 over 1, which is 32. And then put a 4 in for x right here. Put a 4 in, and 32 divided by 4 will give you out 8. Okay, so this is definitely the function I want. My answer would be r of x equals c over x. Okay, alright, so that's the model that I want. Okay, moving on to numbers second. Make sure our answers are correct so far. Okay. Okay, moving on to numbers 83 through 89. We're going to do some difference quotients, okay? So here we go. For my x, first of all, we're going to start off with f of 2 plus delta x. So everywhere there's an x, I'm going to put this right here, alright? So here's what I have. I'm going to write it like this. I have f 2 plus delta x minus f of 2 over delta x, okay? Now, I'm going to take this entire thing right here and get rid of it, okay? So I'm going to evaluate this function f of x at this right here, 2 plus delta x. So everywhere there's an x right here, I'm going to put 2 plus delta x. So I'm going to put 2 plus delta x for this x here, and then square it, minus, then for this x here, I'm going to put 2 plus delta x, and then positive 1. So let's quickly simplify this, and when we're all done simplifying it, we'll put what we get out right here. Okay, so here we go. Okay, when you square this, you're going to get 4 plus delta x squared, and then plus 4 delta x. Okay, now how I got that was this. 2 plus delta x times 2 plus delta x. Okay, I kind of did it in my head, and hopefully I didn't make a mistake anywhere. Alright? So, where I had f of 2 plus delta x, which was right here, I'm now going to pick this up and put it up there in place of it. So there it is, okay? Now, next, I've got to evaluate the function f of 2. So I'm going to get rid of f of 2. I'm going to bring it down here. And everywhere there's an x, I'm going to put a 2. So here we go. 2 squared minus 2 plus 1. 2 plus 2 is 4 minus 2 plus 1 be 3. So we get out of 3. Alright, so for right here we're going to put 3. Now, for the bottom we just have delta x, which is fine. Now, let's see if we can't do maybe some reducing or canceling here, okay? So here we go. And students, I was looking in the book, and the answer in the back of the book, I think I made a mistake right here for f of negative 2, or f of 2 right here. I'm going to go and put 2 in for x again. It would be 2 squared minus 2 plus 1. Let's see. Maybe not. Let's see. 2 squared minus 2 plus 1. No, I guess that would be a 3. Alright, because I'm looking here in the back of the book, trying to figure out why my answer is not coming out to what they have. And that's not what I wanted. Okay, students, I'm back. I think I figured this out. Okay, so here we go. So up top we have a positive 4 and a negative 3. You can combine those two terms right there, and that would give you a positive 1. So I have a positive 1 plus, now delta x squared is like delta x, and then 4, then plus 4 delta x. Okay, now all of this is over delta x. Okay, so what I recommend that you do is you split this expression up into 3 different fractions. Now normally I would tell you to take a delta x away from every term, this term, this term, and this term. However, there is no delta x in this term, so I can't do that. So I'm going to divide this up into 3 fractions. So 1 over delta x, then use the sign right here, plus delta x times delta x over delta x, then use this sign here, plus 4 delta x over delta x, okay? So this fraction here cannot be simplified. Plus, these cancel out, leaving you with delta x. Plus, these cancel out, leaving you with 4 right here, okay? So there we go. Okay. All right. Moving on to number 85. Okay, students, on number 85, here we go. First of all, let's go ahead and everywhere there's an x, we're going to start off with f. I'm going to put it like this. F of x plus c minus f of x all over c, okay? Now, first of all, we're going to work with this right here. I'm going to take this out of the picture and put it down here, okay? So we're going to evaluate this function right here at f of x plus c. Everywhere there's an x, we're going to put x plus c. So here we go. X, if I get my pen to work here, x plus c to the third power plus 2 x plus c minus 1, okay? So with that in mind, now let's go ahead and simplify. X plus c to the third power really means this. X plus c, x plus c, x plus c. And of course, 2 times this is really easy. 2 times x is 2x. 2 times c is 2c. Then bring down your negative 1, okay? Now for these here, I'm going to go really fast. I'm going to use some shortcuts. But if you take x plus c times x plus c, you should get x squared plus 2cx plus c squared times x plus c, okay? And then bring all of this down, of course. So real quick, let's do this. X squared times x is x cubed. X cubed times c would be cx squared. 2cx times x would be 2cx squared. Let's go back real quick. Let's say this times this here. Okay, let's see, where were we? This times this would give us 2cx squared, and 2cx times c would be 2c squared x. Now take your c squared and multiply it through. C squared times x would be c squared x, and c squared times c would be c cubed. Okay, so it's a big mess, but that's what we have. And then bring down all of this after it right here. All of that goes right there, okay? So if I'm going too fast, pause the video. Okay, I'm going to go ahead and move on. Now let's simplify all of this and see what we have for up top, okay? Let's see. First of all, in the bottom here, we have just a c. Alright, now, I know up top here, and more than likely I better move this negative f of x down here a little bit. Alright, now, I've got an x cubed. There's no other x cubes to combine it with. Next I have cx squared, and your cx squared, there's a 1 right here, so 1 plus 2 would be 3 cx squared. Alright, then I have c squared x, 2, and then a 1, that would be 3 c squared x. I have a c cubed, I see no other c cubes to combine with it, plus 2x plus 2c minus 1. There we go. I hope that's right. Okay, now it's really easy to make little mistakes on these. Now I'm going to condense this down to get just a little more space up here, okay? Just a little. Alright, now next comes negative f of x, okay? So I'm going to bring down my f of x. My negative sign will be right over here. Now, minus f of x. Well, f of x equals this. So I'm just going to put this in place of f of x. So negative x cubed plus 2x minus 1. Now, students, this negative sign goes to all the terms inside here, okay? So watch carefully. Your positive x cubed will become a negative x cubed, okay? Your positive 2x will become a negative 2x. And your negative 1 will become a positive 1. Alright, now we're going to pull this down. And there we go. Okay, so we're looking hopefully pretty good. Alright, now let's simplify the numerator here. positive x cubed, negative x cubed, they cancel out. Positive 1, negative 1, they cancel out. Positive 2x, negative 2x, they cancel out. So it looks like we're left with the 3cx squared plus 3c squared x plus c cubed plus 2c all over c. Notice every term has a c. Okay, so let's reduce every term by a c. Okay, so I'm going to cross this c off. Let's do it like this. Take this c away and you're left with 3x squared. Take a c away from here and you're left with 1c. So 3c to the 1 power instead of the second power. X. Take a c away from here. So instead of c cubed, it's c squared. Then take a c away from here, you're left with the 2. And of course, take a c away from the bottom 2. So you reduced every term by a c, and you're left with this right here. Okay, so there we go. That's number 85. Let me check the answer real quick and kind of hold my breath. Hope we got this right. Yes, we did. Okay, number 87. All right, here we go. Let's see what we got here. Well, first of all, we're going to, this one might be one of the easier ones so far. Let's see. We're going to take g of x minus g of 3 over x minus 3, okay? So first of all, g of x is pretty easy. I'm going to get rid of my g of x here. For g of x, we're just going to put what g of x equals 3x minus 1. If we can get this to work here. Alright, so 3x minus 1, and then it says minus, there should be a 3 here, minus g of 3, minus g of 3, so let's go ahead and pull down our g of 3, and we're going to evaluate this function here at 3, so everywhere there's an x, I'm going to put a 3, so 3, parentheses 3 minus 1, 9 minus 1 is 8, so I'm going to put an 8 right here, alright? And then the denominator, I simply have x minus 3. Now, let's simplify the numerator. 3x minus 9 over x minus 3. Now, you're not quite done, guys. Look at the numerator. In the numerator, you can factor out a 3. So you're left with x minus 3 over x minus 3 like this. Do you see that? You can pull a 3 out of both of these. Now these cancel out and you're just left with 3 over 1 or just 3 for number 87. Okay, so there we go, 3. Pretty simple. Alright, number 89. Here we go. This one might be a pretty easy one again, hopefully. So let's see. We have f of x minus f of 5 all over x minus 5. Okay, now for f of x, I'm going to put this because f of x equals this, so I'm going to get rid of my f of x here, and in place of that I'm going to put square root of 5x. Now, negative f of 5, students, negative f of 5. Okay, well, let's see what we got here. Let's grab this f of 5. F of 5 means everywhere there's an x, I'm going to put a 5. So square root of 5 times 5. 5 times 5 is 25, and the square root of 25 is 5. So when you put in 5, you get out 5. So f of 5 is 5. Okay, there we go. Now, in the denominator, I will just have x minus 5. Now, students, I've kind of looked to think of ways to simplify this if at all possible. Please don't do this. You cannot just cross off your 5s because you have 2 terms up top and 2 terms in the bottom. If you're going to do that, you must have a 5 here and a 5 here, and then reduce every term by 5, okay? So there's really nothing you can do. I've studied it, looked it over. I looked in the back of the book, and the answer they have is this answer here, okay? So that's as far as you can take this. Now I will actually, let me get rid of those 5s that shouldn't be there. So there's your answer. Now, I do want to say this in case it ever happens. If you would have had this for an answer, if the reciprocal would have been your answer like this, then hopefully do you remember what to do. We multiply the top and the bottom by square root of 5x plus 5 because you never want a radical in the denominator. It takes a little bit of time. We're not going to do this, but just keep that in mind, okay? Alright, so this would be your answer right up here. Alright, I hope this homework help has been helped you. If you have any questions, don't hesitate to call or email.